Let's see. Yes, everything's working. Fantastic. Good morning, everybody. How is everybody? Hope you're having a nice day so far. Right. Where did we get to yesterday? We were generating some artifacts and we did some placement ordering and we ordered some placements and everything was fantastic. Yeah. Let's have a look. Here we go. This is where we got to yesterday. Generating some artifacts over here. What are the artifacts? What are we generating again? So what we're trying to go from is an EDA design to a list of things that you need to put on a circuit board. An artifact is the list of things that you need to do for each phase of the process to get things on a circuit board. So yeah, so we shall continue with that. Let's have a look. Oh, that's the wrong button. That was completely the wrong button. It's the window wasn't focused. There we go. Let's try that again. Let me fix my OBS thing. Oh dear. That moved onto the wrong screen. So professional. It's just amazing. Right. So let's try that again. Okay, here we go. That's it. There we go. Right. Honestly, we're trying to do some stuff and be professional here. So we've got to update the journal for today. Live stream. Job setup. We're number 12 today. Artifacts. There we go. Paste that in there. Job's good. Alright. So these were the steps, and the artifacts that we're trying to create was this. And yesterday we drew a little thing, this. Order list of placements for each phase and the source for each placement. Where to pick from and where to place. This, technically, is done. Yeah. I mean, the first cut of it's done. But our placements don't contain all the things that they need to contain yet. And I'm wondering when we're going to need to do that. Like if we tried adding a sort order for X and Y, for instance, that would mean we would have to put X and Y everywhere else that we're not currently using it, right? Maybe we should do that. Because I am kind of missing the fact that we don't have X and Y everywhere yet, and then every time we come back to stuff later on, we're going to have to start touching more code that uses the placement to put X and Y in it. So maybe let's put X and Y in the placements today and see where that takes us to. List of operations for each phase. I don't know, at some point we'd probably generate some HTML report as well. But let's carry on with the generating artifacts and the order list of placements and getting this placement sort of more usable, because at the moment it's not usable by anything because it doesn't have X, Y and rotation. So let's try and deal with those today. Let's see where we go. Let's make a note. Adding X, Y rotation to placements. Alright. Right, but firstly we've got to deal with all these work in progress commits. Let's make sure that all the tests pass. Hey, test pass. Everything's good. I'm so glad I bought an AMD CPU and I bought a CPU recently, because when I run stuff, instead of it crashing like it might do on an Intel CPU, it doesn't. Happy days. There's lots of controversy about that at the moment. Intel have really goofed. Right. So yeah, so there's some refactoring to do, but not just yet. I did mention some refactoring yesterday and some extra unit tests for all the different variances and all this kind of stuff. But I feel it's probably more useful to probably put the X and the Y and the angle in there before we start doing some refactoring. So let's squash some commits. And let's just call it work in progress. Oh well, I suppose we could put. But you know, squish, squish. But we need to review this still because there might be some white space and some other random stuff in here. So let's just go git reset head in. This little character probably has a symbol somewhere, but I don't know what it is. You know, like, it's not a tilde. What is this? Is it a hat? Head hat? Is that what you say? Git reset head hat? What is the name of that symbol? Should we look it up? Let's find out. Here we go. Name of symbol. What is it called? It's called circumflex or carrot. Yeah, but it's not a carrot though. Circumflex, really. This is why I don't remember it. But there we are. Hat. Because it looks like a hat. Right, moving on. Hi Darkman, how's it going? Right. Hats. Right, so we're trying to deal with a commit. Here we go. Right, so we've got this placement builder. Let's just quickly review this. Some white space. How dare it? Good lord. Changes. More tests. Let's start with the planner. What did we do? We added a thing to generate artifacts. Added a command to generate artifacts. And it generates some artifacts. Yay. And I guess if we had more phases and more things in it, we could check more stuff. We really kind of need a project with like 2 phases for like top and bottom to be a bit more real worldy. I still haven't cleaned my mouse wheel. I didn't have time yesterday. So when I'm trying to scroll, it sort of scrolls the other way sometimes. Anyway, moving on. Generate artifacts. We added that. That looks okay. Now it's all good. Right, and then what? Oh yeah, we added a mod for that, which is this file here. And then in our planner, we've got a new command for generating artifacts, which doesn't have any options at the moment. And we say load the project and generate the artifacts. Seems fairly reasonable. And we've got various different errors that can occur when it happens. Still want to sort of work out if there's an easy way of reusing existing errors rather than mapping them. I don't know. Let's clean up some white space. That was our sorting and ordering stuff we did yesterday. That actually seemed to work quite nicely, the fold stuff for the sorting on multiple fields. I quite liked that approach. It was pretty good. It was pretty good. I was happy with that. I thought that might be more involved, but the fold works well for that. Surprisingly well. Right, loadout source. Yeah, we did a bit of refactoring there. We got this find loadout by part. Now, some people might delete this bit and then delete this bit here, but I don't do that. The reason is because I can set a breakpoint there if I want to. Sometimes it's very useful to do that. If you don't use a temporary variable, it can be a lot harder to set breakpoints where you want them. Just for any of those watching, why they look at the code later and they go, well, why haven't you deleted that? I specifically don't want to. Naming the things is good. We could improve the naming, mind you. This could be matched item. Oh, what happened there? Matched item. That, yeah, there we go. And then that's our refactoring that we did. That's the same refactoring that we did. Yep. And we added this PCB unit path thing from here. And then say future only works for, I suppose it's to do. And we need to add support for single PCBs. But we'll do that when we've got some code that makes us do it. And then we move the message in here. So yeah. Oh, what happened to that? That was supposed to be in there. Okay, so we've got that, and it does work. Let's run all the tests. Yeah, okay. Let's push that up. Right. So let's go back to the placements. We've got our variant builder, right? We've got some tests for it, and in here we got this test placement record, but this test placement record is missing some things. This is where it all starts. Well, there's the KiCad one as well. We're going to need like X. And I don't know what it's going to be. A Y. I don't know what this is going to be. And I mean, we could use angle or we could use rotation. Let's look and see what both of the EDA tools call it, and try and use and see if there's any consistent naming, rather than just deciding on one right now and going for it. So here it's called rotation in a dip trace file, and KiCad says rot. Okay, we're going to use rotation for it because it seems to be common rather than angle. Right, so go now what kind of units do we need for these? I mean, if it was Java, I'd probably pick big decimal, because I don't want any floating point rounding errors. What's the Rust equivalent of big decimal? But did it do? Okay, let's see if we can find out. Okay. Let's see Rust big decimal. Oh, there's this, yeah, there's a num crate, yeah. Okay then. Apparently I need to restart my Firefox. Okay, let's go Rust big decimal. Like, is this crate even used? I think it might be this num. Crate style. That seems fairly popular. Big int. Generation of random big integers when the round features. Yeah, fine. We don't care about that too much. Like, it'd be nice if it told you like more of an overview. Like, I don't care about the features and all this releases and compatibility and alternatives. Like, what does it do? Tell me more about what it does. Sure, you know, a big integer type, but you know, what about the precision? How do you use it? Give us an example. That's what I want to see when I look at a crate. There's no example. There's no examples. Let's see if there's tests. Big int. From bytes. What does that do? This is pretty random. From bytes big endian. Oh, I just want a basic test of how you're supposed to use it. Little endian from bytes. Like, how do you create a big int? How do you add numbers to it? Is it just big int from? Comparison, okay. Why has it got a minus and a plus thing here? Like, why? Seems very weird. Big int's composing element. It's not really discoverable as yet. Is there an API docs for this somewhere? Is there another one that we're supposed to be using that might be better? Big. Let's search for decimal. That's quite a lot. Is it 1.0? Okay, it's over 1.0. That's good. The other one wasn't. Rust decimal improve Rust financial calculator. So usage. Yes, this is better. Usage tells you how to actually use it. You go decimal to string, scaled to the amount of decimal places. Yeah. Seems pretty good. Okay, and there's Serde support for it as well. That's good. Should we try this one? Should we check our dependencies? Is it this? Yeah. Pipe grep num, and then let's say decimal. No, we're not using any of these yet. So here we go. Comparison to other decimal implementations. Let's read this. Let's look at these two then. Like, I don't think it's a problem for pick and place machine, the amount of decimal places. But let's see. Yeah, no one else uses that. Big decimal. Quite a lot of people use that. This one still seems more popular than this one currently, but it might just be like one very active project that uses it, causing all the downloads. This has got a 0.45, which means it's not stable yet and is subject to change. But let's have a quick look. Turn the fan down a bit. I don't know, I think the other one seems more complete. And we know we need to do serialization. I think we're just going to go with Rust Decimal. And we'll see how we get on with it. Let's see if we can find the documentation and repository. Right, we'll have a look in the repository for some examples. Oh look, there's a Serde JSON scenario. Let's have a quick look at this. Because we're going to be needing to do this, like, immediately. Derive, here we go. That's interesting. Okay. Let's try it. Let's try it. All right, let's go. Decimals. Right, so we'll come back to that in a moment. And we're going to add them. And we're just going to keep them in the same format as we have the other ones. Let's just see. Yep, same version. Okay. So we're supposed to use it just like this, decimal. That seems pretty good. And they're all going to be decimals, really, aren't they? I mean, we don't want rounding errors on our rotation values, certainly. And they're generally sort of like fixed amount of decimal places. These things usually are on pick and place machines. So we're going to go with it. All right. Let's see what happens now. This will be all manner of failures. Let's see what we've got to do. Yeah, it doesn't have all the things. So this is our first test that we want. So I suppose, you know. Now, okay. So a moment ago I did this. Yeah, no, it's fine. It's fine. Yeah. Everything's good. So you can create it from an integer. This is good. So I suppose we can have 0, right? Z? No. Rotation. Now, dip trace. Right. We need to know how dip trace works at this point. So, yes. Here we go. So we've got our dip trace example here, right? And we've got rotation values of 270, 180, 180, 90, 180, 180, 180, right? And this tells me that it only supports positive rotation. And we need to know whether a positive rotation implies that it's rotated clockwise or anti-clockwise at this point. So we're gonna see if we can find out. No. Now I did do this a while ago in the other project that I wrote, the PnP convert thing, but I don't remember, and we're just going to look at it again. And we're also going to see what happens if we try and put in a negative rotation. So, we've got our thingamajigamy, right? Happy days. So I'm just going to copy this placement for a moment. We're going to use this as our sort of temporary one. And we're going to say 0 degrees. Right, and it's like this. And then if I rotate this by 5 degrees, it goes anti-clockwise. Right? So we'll make a note of that somewhere in here. Positive values indicate anti-clockwise. Anti-clockwise rotation. Right. Now, what is the range of this? So, if I say -5 here, what actually happens? Does it say -5 when you open it up again? No. It says 355. So the UI has got a conversion between, so that it always has a range between 0 and 360. But what happens if you specify 360? Does it go to 0? Yes. So it's 0 to less than 360. Let's see what happens if we go 359.999999999, 359 point, and then lots of 9s. I'm just holding the 9 button down, right? And then have a look at it again. It rounded it. Okay, so 359.9. Still there. 2. Still there. 3. 3 was the limit. So 359.999 goes to 360, right? It rounds it. It rounds it after 2. Let's put a 5 there and see what happens. It's like, let's play Guess the Implementation. So, yeah, it rounds it. 2 digits. Rounding occurs on the 3rd decimal, e.g. 359.991 rounds to 359.99 and 359.995 rounds to 0. Well, I guess it's rounds to 360, then gets converted to 0. Right, so that's what we're dealing with. How about KiCad? Righto. This one. Doo-be-doo-doo-doo. I did click it. There it goes. Wow, that was slow. Okay. Oh, I've got to work out how to use KiCad again. So I've got a select item. No. 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 Just give me... Right. Then... It's not very speedy, this KiCad thing. Orientate. I just love the consistency. So in the files that it generates, you get rot, and in the UI it has orientation. Oh, and very happily it's got... Alright. Okay, let's go 5 degrees. We'll do the same things, right? So 5 goes anti-clockwise. Fine. KiCad placement record. So I mean, I'm assuming it's decimal at this point. It probably is. So this was the same. Now, the UI and the placement files don't necessarily correspond with each other. So although I wrote this range as this, we didn't actually check the resulting placement CSV file, which we do need to do. But I'm fairly certain this is what's in there, because I've done some stuff with this before. But KiCad I've got less of a clue about. Right, so what's the range? Range is... So 5 gives me this. So if I have minus 5, and then open it up again, it still says minus 5. What if I go minus 185? What happens? Place your bets. Does it retain that number? Or does it change it? 175. So it wraps it to plus minus 180. And we'll do 185 here and see if that comes up with minus 175. Oh, what happened there? Yeah, so it wraps it. Okay, so we've got a fantastic inconsistency between the two. Minus 180 to, well, We haven't tested the limits yet, actually, because one of these might go to the opposite sign. So let's put 180 in here and then see if when we reopen it, it says minus 180. It stays the same. And if we go minus 180, does it change it to 180? It does. So the range is greater than minus 180. Right, so now we find the rounding point, 179.995. Ooh. So it's got 3 decimal digits. So it looks like it's got one more. So if we put a 5 there, does it round it up to 180? Or does it just trim it? No, it just truncates it. That's interesting. Let's put another 9 there. No, it just truncates it. It doesn't round it. That's interesting. Should we try with another number? Let's go 0001 and see what it does. It truncated it and then removed the remaining zeros, right? Let's go 0.1001 to confirm that. So truncate, so it should say .1, yeah. Okay, so it doesn't round, it truncates. No rounding. Values are truncated to 3 decimal places in the UI. Let's say that. So let's try and export this file. With 005 on the end, right, which should be retained. Yeah. We're going to save that, and we have to fab output placements. Generate. Close. Right. Just what? Why are there 6 decimal places here when the UI only supports 3? Am I missing something? Where is the one that we did? Rot aside, right? We've got 2 R1s, which is fantastic. I didn't even know that was even possible to do. But this is what we saved because this was the maximum, you know, digits we could have. So, but it's like it's formatted it with 3 extra trailing zeros on the end, which seems like a complete and utter waste of everybody's time. And just serves to add confusion. Fantastic. Okay then. Is there any settings for changing the precision anywhere? What do we think? Common. User interface. Project backup. Blah 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 blah. No. Schematic editor. PCB editor maybe. I clicked it. Grids. Oh, there are grids. Okay, everything's fine. I don't see anything. Wait, were there tabs on one of these other things? I don't know what's going on here. Do you need to add something? What does this do? Plugin directory? Don't know. Oh no, I don't see anything. No. There's no scrolling. Okay, I don't see any options for it. What about view, drawing mode, precision? Can we see in help? Sure. You were having a quick look. I'm not going to spend too much time on this because it is what it is, really. But just in case there is some random setting that I don't know about, we'll have a quick look. I want to search for precision. I mean, sure, SVG options. Where's this? Placement files, you see, does it have precision in there? Oh, that's annoying. I want to see the entire list. Precision. I have to keep searching for it every single time, that's annoying. And it keeps taking me to the same thing. I mean, it doesn't seem to make much sense being able to export more than 3 digits if you can't enter more than 3 digits in the user interface, right? I don't know. Anyway, that's my take on it. Right, we'll get rid of that and we'll save this again. And we're just going to revert these. Ah, don't do that. Roll back? Yeah. Go on, off you go. Okay, so what do we discover? Values are truncated to 3 digital decimal places in the UI. Right. Okay, let's just try and compile everything and see what happens. So we're going to need to specify some values in these placement records. It feels like we should use different values for each of things. So, I don't know, we'll go 10 across on the first one, 20 across on the second one, 30 across on the third one, 40 across, so that we can see the differences in the CSV file and make sure that all the values are coming through and they're not all just coming through as 0 accidentally. And we'll do the same here, 10 across. But then you could have transposition errors between 10 and 20. So if we say 100 and 100 110. We'll start at 100 and just increase it by 10 every time instead, right? Should we do that? Should we start it? Or should we start at 110? Let's start at 110. And then you have to think less. Oh, there's still more. Oh my god, there's quite a lot in here. Oh, typed the wrong number there. And then we'll come back and add some angles to these in a minute, or rotations, or whatever you want to call it. 90. Right. I don't know. Let's say 0 for the first one. 90. 180. 270. We can't have 360. Let's go 45. What's it's 135? Is it? Is it? 90 degrees plus 45, 135. Seems about right. And then the next one is 180 plus 45, 225. The next one would be 270, 315. God, maths. And let's give 5. I don't care. You know, right. We've got some numbers. Everything's fine. Then we've got the KiCad ones, which we've got to deal with, but these are different. So here we're going to specify a negative one, and we said we can go up 179.999. Oh. Oh, why not? Okay, we're going to have to come back to that. We're going to say 10 and 110. What do we do here then? So we can't create it like that, so we need to go back to the manual of how to use this Rust decimal. There's a macro. Sure. Okay. Surprisingly, everything works, but yeah, I think we need to update the expectations. Like, the generated output file should probably contain some numbers in it. You know, but he didn't break the serialization and deserialization, which is good, I suppose. Okay. Expected CSV content. Right. So this is what we want to get out of it. So we need to say some other stuff here. Let's remove all these slashes here because we found a better way of doing that. which was this literal string format thing. Why it does that? It's weird. I think it's the IDE trying to be too clever and failing every time. Okay. So let's put X. Now, and then we've got to go, well, what do we want in our rotation thing? Do we want numbers between 0 and less than 360? Do we want to go with the negative and positive things? Like our internal representation, what's it going to be? I don't know. What I do know is the Charm High pick and place machine uses 180 to plus 180 in its ranges. Not that that's any I don't know. Maybe it's useful to know that. Maybe it's not. And then rotation. And then R1 is this is the KiCad one. So, and this we've got a decision to make immediately. Like, do we want this value in the CSV file, or do we want whatever this is converted to 0 to 360 degrees? Yeah. Do we want to be flexible? Do we want to store it in the same format as the input? What are we actually asserting down here? So these placements down here, not that, this. I think these placements should be in the same format as the input. So if you're using dip trace, you get dip trace rotation values out. If you're using KiCad, you get KiCad rotation values out. It's only when you come to take these placements and convert them to our internal structures that we need to care about the converting it from a EDA specific rotation value to an internal rotation reference thing. Do we do that in the bit of production code that we're trying to write a test for? That is an interesting question. We know what X and Y is anyway, so we'll put those in. Somewhere, there they are. 10, 110. Oh dear, right, 10. Trim trailing digits of it. Seems reasonable. 110. And then what? Oh dear. Was it minus 179.999? Question mark. Don't know. Let's put question marks like this. Why have I got 179? 100. There we go. 197. Right. Let's have a look. So the variant builder. What's it doing when it writes a CSV? Somewhere we've got a write output CSV, and this takes placement part mapping results. I've completely forgotten all this code. We've got an EDA placement, so we're dealing with our internal structure here now. And an EDA placement is what we're going to need to update to have the appropriate X, Y, and rotation fields on it in our format, in our notation. So I guess we're going to need to add those to here in a moment. So let's do that. So this is what we said here. And this is what we're going to say here. Now, I kind of want to know what the other tools do. And I know that KiCad is very popular, and likelihood is that more people using this software are probably going to be using KiCad than DipTrace. I don't have things like Ultim Designer and Eagle and Easy EDA installed on my machine. And again, those are less popular tools. Easy EDA might be popular. Let's have a quick look at Easy EDA. Let's have a look. Oh dear, I've got to log in. Give me a moment. Let's see if I can log in. Oh dear. Oh dear. I've got to do captures and everything. Not that one. How about now? No. Oh dear. Oh, hold on. Oh, it's more complicated than I thought it was going to be. Yeah, okay. I'm getting there, honestly. Oh, I got a typo in my password, that's what happened. Fine. Okay, we're in. Okay, so Easy EDA. It's making me go through some tutorial. Okay, let's just go new project. Test. Space or R to rotate? Yeah, I don't want that. I want to. I don't know. We'll do that. Update PCB? No. How do I go to looking at the PCB? Design Manager? No. This one, that one? No. Where do you edit the PCB? How do you edit the PCB? Who knows? Save. Close. Then what? Where do you edit the PCB? Convert schematic to PCB. Oh, there you go, look. There we go. It's a bit weird that the language convert, it sort of seems to imply that you won't be able to change the schematic anymore because you converted it, as opposed to build a PCB or design a PCB. Anyway, start. Let's go 0 and 0. I mean, why have they got these weird numbers like that? 100 millimeters. Interesting. Okay, fine. So we're going to save. You don't double click. So we've got a rotation here. Here we go. At least it's called rotation in here as well. Let's say minus 181. Then what happened then? Right, so it uses the same. Well, hold on. Let's say 5. Oh dear, I rotated a pad. Don't think you ever want to do that. Okay, so easy EDA is the same as KiCad in that regard. Let's see if the amount of digits are the same. Ooh, it's got more. It's got many more. Ah, there it goes. It rounds eventually. 6, 7, 8, 9, 8. Yeah, 8, and it rounds. Fine. Oh dear. Is there a way to duplicate it? Copy? It'd be really nice if these tools all had a duplicate in place, and then you could adjust them with a keyboard afterwards. Paste. Yeah, you see now then you have to realign it with the original one. It's just like paste in place, move with cursor keys, shift, move it a bit more. You know, maybe the next thing I'll have to do is design an EDA tool that doesn't suck after we've done all this pick and place stuff. No. What was I doing? Yeah, so we were trying to see what happens to the other side. So minus 179, just to see if there's any difference in the rounding. Oh, that's interesting. Look at that. Oh no, okay. So is that 8? Yeah, 8 decimal places. Okay, fine. Save. Alright. So we've got two tools that use minus 180 to plus 180 for rotation. So let's just go with the common denominator of the things that makers are most likely to be using, because it seems more reasonable. And do we want to round things, or do we just want to truncate things? Probably we should round things. Let's say rounding I mean, maybe we want to specify some preference somewhere to say when rounding or truncation should occur, like how these things are processed. Maybe there should be a rotation scheme, for instance. I don't know whether we want to go that far. Let's just completely ignore the rounding for now. Defer that decision to later. And let's just not do any kind of rounding whatsoever. And we're good. Yeah. And then maybe we need to add rounding at some point. Is that a good idea to do that? Maybe we should have like our rounding scheme thing, and we always round things when we write. I don't know. Let's ignore rounding for the moment. Just lift the rug up. There it goes. Goodbye. Problem solved. Bad developer. Oh dear. I don't want to think about it yet. I know I need to think about it, but just not yet, okay? Just leave me alone. Right, so decimal. So like x, y, positive, what does it mean? Negative, what does it mean? Which way does it go? Does it like go up? Is it Cartesian coordinates, for instance, you know? Or is x mean go left, or does x mean go right, you know? So we can have a quick look at the PCB tools, right? So here we've got an origin, which is 0, and here we've got a part, and it's got an x of 12. So we've got positive right and positive up. Okay. Yay. Let's have a look at another tool just to be sure. So here we've got an origin. It says 0 and it says 0. And here I've got a thing. Wrong coordinate scheme, easy EDA people. Look, so they've got positive right and then positive. Oh wait, no, they've not. No, everything's fine. It's just that when it. No, I want to move it. I don't want to drag that. Why did you do that? That's crazy. Do you move it with the right mouse button? No. What about middle mouse button? No. Canvas properties? That's crazy. Look. Have they mixed up the start and end? Or is it... What? Start x 0, end x 100. So sure, 0 to 100. Right? Start y 0, end y. What? Why does it say... Oh, this is track properties. No. Why does it do that? What if, how'd you place a PCB? How'd you put a PCB down and do it? Canvas. How'd you I want to create a rectangle. I don't know what this rectangle is. Oh gosh. Oh dear, just no. I want to look at that user interface dialog thing that came up. Can we delete this? Yes. Yes. Go away. Okay. Design. Convert to PCB. I'm not converting anything. Look, I'm looking at these numbers. It's got 0 and 0. And then it's got width and height. Right? Width and height. I typed in 100, 100. And what it creates is a box going down. Which is all manner of madness. Wait, what? Layer, board outline, yes. Length, 400. Why has it got 400 there now? What? Oh, wait, hold on. Was it just not selected? Why can I select this, but not select this? Oh, now I can select it. Oh god, this tool. What about zooming in a bit? Click, 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 click. No? Anybody? Bueller? There we go, finally. Jesus, that was painful. And it's probably moved, but it's got minus. Okay, so at least we know that negative is down, but the way that you create a box with this tool is stupid. Moving on, I'm glad I don't use that tool. Okay, so at least two of the popular tools use the same coordinate scheme as this. And DipTrace does that as well. So it just everything in DipTrace is just like easier. Look, just like I'm moving the box, I'm clicking on it, it's fine. Do you want to resize it? Do you want to resize it? Sure, you can just move it around like this. Do you want to resize the track of this in? Yeah, you know. Click, move, job done. I don't know how you select multiple points there, mind you. I don't think you can. Well, most things are easier in DipTrace. Yeah. Positive up. We're all good. Now, I believe this coordinate system is called this. So we've got positive up and right. So we're going to make a note of this, and we're going to link to the Wikipedia article. Why did it do that? Is it because I got too much selected? Yes, it is. Let's move this comment to here. Jobs are good. Now we'll have a quick look at this because I don't think the Cartesian coordinate system specifies anything to do with rotation. Z is up, yeah, but which, if you want to rotate something, let's see. Here we are. Orientation and handedness. Right, so we've got rotation, and we said a positive value gives us an anti-clockwise rotation. So a positive value gives us anti-clockwise. So right-handed that's what we're doing. We're done. We've decided. There we go. Woe betide anybody that wants us to do anything else. So all our conversions need to go from whatever coordinate scheme some other tool uses to right-handed. And then when we're dealing with pick and place machines, we need to go from whatever internal representation we've got to whatever the machine uses if it's not currently running MakerPnP, which doesn't exist yet. But internally, we're going to use that coordinate scheme as well. Now, what implication that has on borrowing other people's algorithms at a later date, which may use a different coordinate scheme, I don't know. But you can always convert from one coordinate scheme to another before you do it. So anyway, so let's make a note of this in our logsec. Right-handed. No. Can't remember how to spell it. Oh dear, what happened there? Cartesian coordinate system. Right-handed, please. There we go. And if we steal that and then put that here. There we go. And then if we go right-handed and just have a link to orientation and handedness. Can we have a link to this? Orientation and handedness? Yes. Copy link. Yeah, good. Boom. We're all good. Now what? Try compiling it, I suppose. Right. So, EDA placements. Private fields. Oh dear. Yeah. Probably going to need like a default for this thing. Because I don't really necessarily want to specify all these things. I mean, here we do. And this is where we get our first problem. Because we need to go from the dip trace rotations to the internal representations, which are different. So, the X and Y is easy. And this this is going to be dip trace placement record, build EDA placements. So we go is self dot did we not have that? Did I not make them pump up? No. Oh, we don't have them in here yet. Okay, fine. So these records are the same one that we use in our tests, which are, again, these. Oh dear. Right. Duplicating the comment from the tests to the non-test code. And now we can get the X from here. And we need to specify rotation, and we're going to say just temporarily, because we're going to have to deal with this, we're just going to say decimal 0.0 for now. And put a to-do there. Just so that we can keep things compiling, and then we'll come back and do the to-dos. And now we've got the KiCad one. No, I pasted the wrong thing in. So we need to find... Oh, damn it. I pasted the wrong one into the dip trace thing, didn't I? Why didn't you guys tell me? Where's the dip trace one? There's the dip trace one. That's what I want. Copy this. Into... oh dear. This one, right. I'm getting everything confuzzled. There. That's what dip trace does. That's what KiCad does in the tests. Right, so building stuff. Right. Because we ascertain that these are all okay. And this one can be self.rotation. Because we said we're going to use the same scheme. The dip trace one we can't do yet. So we've got a failing test, which is what we expect, because we're not writing these things. Expected CSV content, and what we got was this. There's no like show difference button in this. It gives us like a diff output, but I want the IDE to show me the diff. So anyway, yeah, we haven't got these extra fields or the values written to the CSV file, and that's probably because in the variant builder where it writes the output CSV, the placement record doesn't have the X, Y, and the rotation on it, right? So we're going to borrow the KiCad one again. And find the placement record. This thing. And schlep them in there. And then we'll say C placement for details of coordinate system. This should be EDA placement. Okay, seems reasonable. And now it's going to say can't create one of these because we didn't put things in the right place because we're an auto developer. And now it's going to say missing fields, which is good. Now, we're going to assume the default serialization for surday and decimal is fine for now. And then when we know that we want something else, we can come back and change it. Because I don't want to be putting like 6 decimal places on when you don't need any decimal places and when you don't even support 6 decimal places, for instance. So we'll just go with the default, which probably trims decimal places or keeps all the ones that you specified present. Okay. So we've got another failing test, and it fails because we've probably got the X, Y, and the rotation in here now. Yeah, we do. So our test expectation here is wrong, which is good. That's a good thing. That's a good problem to have. Right, and then we're going to fix this up. Like so. And we're going to say X, Y, rotation. And we've got some numbers which we need to be able to guess at. Well, we actually know what they are. With the exception of the rotation. So we'll put them on. I'm just going to paste them all in for now. And then we're going to come back and fix the numbers up. So R2's missing. So 3 is 30, 4 is 40. D1 50, 60, 70, 80, 90, right, fine. $60, $50. Right. But we've got the rotation, so the only thing that should be different now is the rotation, because this is a dip trace one and we need to convert it. So to go from 0 to, well, what do you need to do? We need to go, if the number is over 180, then take 180 off it or something like that. Something like that. Let's do a unit test for that. We've got to find some code. This bit. Let's write a unit test for this. Does it need to be public? I don't think it needs to be public. Build. Sure. I mean, no. I don't want to test the building of a placement. No. Rotation conversion tests. Let's just do this. Let's start with this. I know I want a parameterized test for this. There was a crate that was using parameterized tests, which was good. I think it was called RS test. Fixture-based test framework. How do you do a parameterized test? You do it like this. Great. Let's do this. RS test. Dev dependencies. RS test. Okay. Is it like God? I mean, everybody uses it, right? Oh, I've got the version. That's why it's not finding it. Okay, 0.22 is the latest. Fine. Great. So we need to create a new test using RS test somehow. Where we want to parameterize tests. So we're going to do this like it says. And we'll slap that here, I suppose. Yeah. And then we do this kind of thing. And the cases, yeah, we'll look at that a bit more soon. Does it need to be pub? No. Okay. So we want an input and the expected output, right? So we have an input of 0 and expected output of 0 is great. But if we have an input of 360, we're supposed to get 0 out. Because there's a whole wraparound thing. Yes, and I know that the file can't even contain 360 anyway. But let's just go with that because it's going to force us to write the wraparound stuff, right? Case, which isn't very difficult. And then if we've got 185, it needs to be minus 175. Let's just go with those for now. That should be enough to get us started. I suppose let's add the minus 185 to 175 case. You know, positive values, negative values, all this kind of stuff, right? Right, so how's it supposed to work? So you're supposed to say value, and then this needs to be a decimal, and then an expected value, which needs to be another decimal. But the problem is these aren't decimals. So if we go dec, I suppose we can go like this. it was so close. No. Damn it. Oh no. Ah! I guess we have to do it like this. Oh, we're missing a bracket. Wrong case signature should match the given parameter list. Right, yeah, we know that. We're supposed to do this. I think. That's what it says. And yeah. Obviously this is not going to... Alright, there we go. Okay, so... Let's see if we can run this. It's not going to know about the deck macro. We need to import that, I think. Oh dear, what happened there? Yeah. I have to edit this, click this, run that, click that, do that. Import this. Okay. Cannot find Mac. Oh yeah. Sure. Okay, so we've got some other compilation errors, which we need to deal with before we can run the test. I knew that was going to happen. Now, this test doesn't care about these extra fields for this EDA placement. It doesn't care about PCB side, and I knew this was going to be a problem. And it doesn't care about the place thing either. Right? So what we're going to do for EDA placement is implement default for it. And then we're going to say self. And we're just going to add all the missing fields. And we're going to use default for everything else, right? And then maybe instead of doing this, we can go EDA dot EDA placement default. Why has it done that? Can I use a comma? Okay, all right. Right, so we're doing that. Right, because there's no need to add these things. Because this test is only interested in dealing with the placement fields and the ref deses. It doesn't care about these other values. Okay. Okay. Empty ref des variant list. This doesn't care about it either. Oh, oh dear, what happened there? That's it, one too many. Yep, same deal here, I think. Map parts. So we don't care about the side? No. We don't care about place either. Where were we just then? Let's put that here and take this off. There we go. And there's going to be some more of these. Doodly-doo, I'm getting there. Last one. Okay. Oh no, there's always more. If we see one that's got different values, we'll go back and fix it. Place true PCB side top. Oh. How about now? One more? I think there's one more. Oh, there's more. Place true PCB side top. Place true PCB side top. Place true PCB side top. Okay. How about now? Hey, it compiles. Alright, here we go. Look. So, finally, we've got some stuff. Can I double click it? No. Can I double click it? No. Can I double click it? No. I knew it was going to get that problem. RS test people, IntelliJ people, sort it out. I can't double click. I can't go to my test. Right, so if it's 0 and 0, we've got it works. But, you know, we need to do something else. Let's go impl dip trace rotation converter. In order to do an implementation, we need a struct. Sure. Let's go pub fun convert. And then we'll say input decimal. And it gives us a decimal. Now, should it be a decimal in the output, or should it be a structure so that you know that this type of decimal is a rotation thing? It probably should, but let's do that later. So, as in our rotation thing here should be, it should probably be rotation like this. But we didn't do that. So let's go back to where we were and just go with decimal for now. So if we return the input and then call the method, which is going to be dip trace rotation converter convert value. I don't know why it's gone red here now, it's a bit weird. Who knows? Anyway, it still passes, so that's good. So now we need to do some other stuff in here. Probably something like, I don't know, while the number is negative, like keep adding 360 to it until it's positive, or something like that. Or the other way round. So let's go while input is less than, no, greater than 360, but probably needs to be a decimal as well. Input equals input minus decimal 360. Can we do that? Are we allowed to do that? How'd you do it? What's the API for this? Who knows? Minus? Subtract? Oh, here we go, look. Subtract 360. Does subtract give us a new one? Yes. Okay, so maybe 2 tests pass now. No. Greater than equals. Okay, so we've got 2 of the 4 done. This is good. So the next one, this one. And then I suppose we have to go, if input is greater than 100, greater than equal to? What did our range say? I forget. We need to do the extents, don't we? Less than 360. But the EDA placement is... Okay, so while it's greater than... If it's greater than 180... And then I suppose we go input is input dot sub 360. Maybe. Yes and no. So that one worked. Is our test wrong? I think our test might be wrong here. If it's mine, oh yeah. Right, so we need to go the other way. I don't know how valid this test case is, but let's fix it anyway. So I suppose we can go while input is less than 0. Input equals input dot add. Yes, and I'm sure we could calculate the difference and add the difference plus 360, but I'm just going to do it in a loop for now. Oh yeah. Add. That's what I had before. How about now? Hey, everything's perfect. Right, so now we need to do the extents tests on this. So if you say it's 180, you should be able to get 180, right? Is that the only one we need? So if we say minus 180, it should be plus 180. Everything's fine. Ta-da! Done. So now we can use our amazing function convertery thingamy-jigamy. Yes, we know it's not. We know it's never converted. It's fine. I don't care that it's not converted, not created. But I don't, you know. So we need to go convert. And then we give it the input, which is self.rotation. There we go. Go. And then run the other test. Is the one that was failing now going to pass? No. Why? Oh, because we haven't set the expectations. Duh. But since we know the unit test is working, and we've written tests for that, we know that those values that it spits out, given the inputs, are correct. So we should be able to just grab the values from here now, which have been converted correctly. So let's do that. And then we don't need to engage our brain as much. R1, 0, everything's fine. R3, 180. And we can have a quick look at what the original R4 value was. So we're saying minus 90. R4's original value is 270. Yeah, take 360 off that. You get minus 90. Yeah, that looks perfect. And if it's right for one, we know it's right for the rest of them. D1, 45. And I'm happy to see that there aren't trailing decimal digits on here in the default serialization for this thing. Right, how about now? No. Did I mistype one? D1, yeah, probably look at this. I've got D1. Oh yeah, put the number in the wrong place. Fine. Typo. Okay, so now the KiCad one. Let's deal with the KiCad one. So the KiCad test, we said we wanted those values in it, and we didn't know whether we were going to keep this, but we do actually want to keep this. So it should pass now, right? Everything passes. Yeah. We've dealt with rotation. Yeah. Let's run all the tests. Yeah, okay, well, you know. We've got some failures. Okay. Well, yeah, we're missing some fields in our test, so that's fine. Yeah. So we need X, Y, and rotation for all of our things now. That seems fine. So X, Y, and rotation. And we're going to go 10, 110, 0 for the first one. And because I know I've got another couple of resistors coming up in this, I'm going to start at 30. And here I'm going to go 40. And we'll do 0. The next one will be 90. This one will want 80, and then 270 here. Sure. Now we're not storing these rotation values anywhere yet. We need to update this one with the new updated placements. So we've got R1, R2, and then this one. Let's see what happens now. Now, you see, everything passes, but that's no good. I also want to change these a bit. Let's put 1 in front of everything. And add 1 to each of these. Dip trace we're dealing with, aren't we? Yeah. Because we want to know that when we get an updated CSV content, all of the placements have their positions and everything updated as well. Potentially we should do the PCB side ones here too. Right. See, nothing changed, so clearly there's some brokenness going on. The placements. This is the placement, and the rest of this stuff is the state. So we're going to need to put on these values in here. So C1 is 3130. And then we've got a rotation, but this is in a dip trace format. Which means that we have to convert this to minus 90 for J1. Yeah, okay. But we're doing C1. 180, 180 is 180. So 180 here. And we said minus 90. J1, 40, 140. R1, 10 and 110. Right. Now we're going to have some compilation errors now because it's not expecting these things. Do we have a reference to a decimal here? Or do we have a... What do we have here? Not really sure. Should we just take the decimals? Yeah. So we have to repeat that stuff like everywhere else. Oh gosh. So C1 comes from this lot. Right, but C1 got updated. No, it didn't get updated. Fine. J1 comes from this lot. But we said we want it to be updated with a 1 in front of everything. J1? Where's J1? 131, 130, 181. Oh, okay. Right, but it can't be 181. It's got to be minus 179. Okay, and then we've got R1, which is going to be these numbers. One, 110. Okay. And 0. Well, 1, right? Yeah, 1. And R2 is going to be this one. That's what we want. And then because the other tests use the same one from the previous test, we can borrow those. Oh, I suppose we can say where we see this. Oh no. What happened there? Paste the same thing in again. Uh oh. Oh, jeebus. Damn it. Yep, no, that's right. So now we're on J1. Oh dear. Bit of duplication, but what are you going to do? Okay. We go back up to the next one, and we've got R2. But I missed R1 for some reason. Not quite sure how I missed that. Still, there we are. Oh dear. Okay, we get right. So now that should all be okay. We missed one. Yes. So we need X, Y, and rotation. Right, and we've got to deal with these. Placement map. Yes. X, toString, and then a value, which is going to be a JSON string. And this is going to be x.toString. Y and rotation. Okay. And if there was special formatting and so on like that, that's where it would end up being. How about now? No. And the reason it's not doing that is because we've not done any updating or copying things, probably. But let's have a look and see what the difference is. Yeah, so we've not added them to our production code where we store the placement. So yeah, but we've got a failing test. This is good. So variant builder's where we do it, right? And somewhere where we do, what do we do? What do we do? Not the variant build planner. That's better. in the planner we've got a command which assigns a variant to a unit, and we refresh the from design variant. This is it. Then we load all the placements and we refresh the placements. Right. Does this placement have those values in it? No. So we need to add them here. Right. Yeah. So we've got our placement record, but currently they don't go from the record into the placement at all, because our build from, our as placement record doesn't copy the things across, because our placement doesn't have these properties in it. So we've got our placement record. Which needs to be built from an EDA placement. Which, yes, arguably is a little bit confusing. Okay. Right. So now we need to convert an EDA placement to a placement. Which should be like that. But it still doesn't work because the placement record. Oh, that's interesting. Okay, maybe I don't know what's going on right now then. Oh, I think it's okay. It's just dumping out more information than it did before. That's okay. But because here the placement has now got extra fields on it, right? So the first placement has got these extra fields on it. The second placement I'm making sure that I'm copying the right ones across here. Is that one. And then the third one, J1, is this. Okay. Still got a failure. Right, we've got a difference. So, what conversion are we doing here? Are we already? No, we're already in the right format, aren't we? That's why. Yeah. There's no EDA dip trace conversion thing going on, so my assumption in the test was wrong. So we're supposed to be using 0, 180 and 270 everywhere. But we're not. Because these are invalid values for here. So C1, we're going to change this one to be 180, so that's 180, so that's okay. J1 should be minus 90 up here. Okay. Still failing. Oh. Okay. Is my expectation wrong? Yes, I think it is, because I've got 0, 1, 80. So R1 is 0. Yeah. Okay, how about now? Okay, that one works. Next test. Right, unmaxed order placement. Yes. Because we need to print out the details of R2. R2, we decided this is wrong. This needs to be 179 here. J1 R2 is going to be 120, 120 and 91. These values. R2, there you go there. Right, and it's going to print out all the details of C2 again, which we already know has, sorry, C1, which we already know has these values. Marking placement as unused. That one. Now we've got a bit of code that's missing, which is going to be the bit that updates the placements. But this looks like it's just a typo. Or does it? This is on J1. So J1, it's got 179, and in the previous test it was minus 180. But our test assertion is wrong because there's supposed to be a minus there, and it's got the wrong number here. Oh no. Which probably got repeated everywhere. In these tests. Okay. Right. Getting there. Right. And this is where it's not updating the values where it's supposed to be. So in the variant builder, not variant builder, in the planning thingy, this, where we refresh the placements, we need to deal with it somehow. Find placement changes. And deal with it. Where do we do it? I thought this would do it. Do we? What do we do here? I thought we had some code which did some updating of these. Where we refresh the parts, we futz around with it. I need to say sort of like updating placement or something. So that we can see what's happening here. Yeah, okay. Let's say debug updating placement. Old, new. Probably used after move or something, but maybe not. Let's see what we see in the log. Do we see an updating placement? Yeah, we do, look. Does it all have the same value? So we've got 10, 1, 1, 1, 0, and then the new one, 1, 1, 0. Yeah, no, that's right. It is doing it. Yeah, so we're updating placements. Okay. Why? Maybe it's in the the problem's in the test setup then. It's probably in the test. So R1. Let's see if we're supposed to have this. So updating placement R1, right? So this is our expectation, yeah. Our expectation is wrong. We haven't updated it. R1. Because we said, yeah. That's supposed to be like that, isn't it? With ones in front. Which means we probably made the same mistake here and here. Any more for any more? Yep. Right. How about now? Oh, passing tests. Oh, this is good. We need to do a commit because we've been far too long without doing a commit right now. I mean, all we've been trying to do is add the X and Y stuff, so, you know, it's... and the rotation. So we've not really done anything else that we weren't supposed to do. Let's run all the tests on the command line and see where we're at. Okay, all the tests pass. We've got some warnings. Do we have the warnings in the IDE? Yeah. Yeah, this is where we use the default stuff instead. That's happy. Okay. No warnings, all the tests pass. Happy days. Okay. Now where are we now? I mean, all the tests pass, and let's have a look at the last thing that we did. Right? Because what we're trying to do is generate the artifacts, right? So the artifacts are now supposed to include the X, Y, and the rotation. And I did so many things I can't remember what I've even done. So we're going to have a look at the tests for the planner. And we're going to look at the last thing that we did. And hopefully there's some assertion which says what the expected content is supposed to be. Generate artifacts here. Yeah. Yes, we're not finished. We're not finished. So the phase placement record, which is part of the artifacts, doesn't contain the X, Y, and the rotation yet. So we're going to need to add that to this. Which means we need to add some fields. And we're going to go decimal 0. But we're going to start at the 10 again, but this is R2, so this is going to be 20. 20. And then the rotation, this is the second one, so this is going to be 90. Right. Because this is R1, right? So that's what we said we want, but we should have a failing test now. There we go. Failing test, so we're missing the columns. So when we write the phase placement records, we're not adding those on. So let's find where we're doing that in the production code, which is this, and then somewhere in here there's a generate artifacts that we did yesterday, phase artifacts, and then somewhere here we store the placements as a CSV, which is done here, which means that this thing also needs these on it. So then we can get these values from the placement, and they're already in the right format. Okay, now it might work. No. Close, but no cigar. What happened? Are the numbers wrong? Yes, the numbers are wrong because we added 1000 to them in one of the earlier steps. So that is okay. So these are all this, and we added 1 to everything, so I think it should be this. I might be wrong on one of those. But no, I was correct. Ta-da! Ta-da! We've got artifacts with X, Y rotation. Oh, I call that a success. I call that a success. Fantastic. Alright, let's do a commit. Come on in. What do? Yeah, I suppose updated the variant builder. Let's have a look. Should we just go placements? Added X, Y, and rotation. Added EDA specific conversion. Now, we only added 1 conversion for dip trace. And ideally you want to sanitize the input to your system before you deal with it. Now, I don't know whether the KiCad output has been sanitized by KiCad as it writes it. I don't know that I trust it. And I don't know that I trust it against future changes where it might break, where it might break our system. So, for instance, all of our rotations are supposed to be between minus 180 and plus 180, right? But if KiCad decides to suddenly write out minus 270 or something, that would break our system. So we need to fix it on its way in. So I'm going to add a to-do. It's going to be very simple. It's going to be very similar to the dip trace one, mind you. Once I can remember where I put the dip trace one. This one. Right, so we've got this. We basically just need a KiCad one that does the same sanitization that we're doing here, but without the additional step of converting it from 0 to 360 to minus 180 to plus 180. So it should be fairly easy to do. But we're just going to go to do sanitize in rotation. Or sanitize? Normalize? Normalize. Build EDA placement to normalize rotation in case KiCad uses values outside its range. We've got to do. You know, yeah. Right. Okay, so we did this. Added. Okay. Dip trace specific rotation conversion. Right. Let's not lie about it. We didn't add more than one. Yeah, we did that. And yeah, we added a bunch of values everywhere. And now the tool is actually kind of useful. So the variant builder is actually useful now. Oh yeah, it's where we added all the things, everything, yeah. Now, there was one thing we did in this planet, which was to add that this extra debugging information on this, right? Where do we do it? Here. I feel that we should assert that in the test, because that was sort of critical to know that the placement should be updated, and therefore we're going to change it to an info, and we'll do the same with the other ones. Yeah, it is kind of critical. Was it? It was this one. It was where we assign the process to parts, and we've got an updated list. So as this, we've got this updating placement. And that came before the change to R2, which is here. And we need to sprinkle stuff. got the new and the old values for it. Yeah. Did we get it? Yeah, we got it. Right. And then we've got this one, which was also updated. And that came after updating R2. So that goes here. Oops. Okay. And maybe we should be using those Rust literal strings here. Feels like we probably should be using them here. But we'll change all of them at the same time when we change them, if we change them. But until then, we're just going to be consistent. Okay, everything still passes. This is good. So that's what we did. So let's add that in here. Assert placement updating messages. So we did that. There's quite a lot of changes here, isn't there? Look at this. Then we provided a default for EDA placements. Yeah. 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 That's our little converter. Using RS test. That's our first parameterized RS test. RS test. Oh, it's like display port. You know, if you named your framework like Spock, for instance, right, then you can say, oh, we've got a Spock test. And it doesn't sound terrible. But if you have RS test, it means you've got an RS test. And it's stupid to say. So, if you name in your project, please try and help your fellow developers out by not making them repeat words twice, because it's silly. And the same goes for people creating ports for back of computers. Don't use the word port in the name of your port, because then you have an export port. Arr. And if you name your product and you put it in a box, and the product ends in the word box, for instance, Xbox box, that's also bad. Take the Xbox out of the box. Put the Xbox in the box. It's an Xbox box. Arr. Rant over. Oh dear. The things. Right. Reviewing commits. Still reviewing commits. Everything's fine. That's our defaults that we said. Yeah. And then this is where we use the defaults in a few places. There we go. Right. So that's all good. Well, what happened here? Yeah, that one's okay. Right, I'm on the wrong one. Yeah, okay. What do we do here? We EDA placement, yeah. Yep. Well, there's a lot of changes for this, wasn't there? Look at this. Far-reaching. And this is the defaults again. Honestly, the defaults was like the bigger, a larger change than the other one, I think. That was pretty useful, that was. Potentially we could have done that as a separate commit. Now let's just check this placement. So positive 108, so yeah. That's good. I think we've got everything. We've got everything. And then the cargo log file. Oh, it's RS test has imported, added a load of extra dependencies, hasn't it? ArrayVec. I mean, oh, no, the decimal's done it as well. Okay. Let's have a quick look at cargo tree and see what it spits out. RS test. Look at all the dependencies for RS test. Wow. Okay, what did decimal bring in? Because we added decimal as a production dependency. I'm not too concerned about the test dependencies. I don't want to go mad, but decimal. Rust, it was called Rust Decimal, wasn't it? Rust Decimal. Yeah, that's not too bad. ArrayVec. Oh, that's good. It's brought num traits in as a transient dependency. Likely we'll probably be using that for someone else. Although I might be thinking of enum traits. Yeah, our dependencies are still pretty good here. I'm happy with that. Okay, so we can do the commit. Commit. Da 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 da. Checking for to-dos. We've built up quite a lot of to-dos. I don't know if anyone's been following this, but our to-do list is getting fairly large. It's not hideous. I did review some of this yesterday after the stream. Well, again, we're trying to build, well, whilst not introducing too much tech debt as possible, we're trying to build the big picture and make sure it's usable. So we're still in generate artifacts here. I don't know whether we want to generate all the artifacts right now. I kind of want to do a bit more than just the placements. But I think we're going to call it there for now. I need some food. And we've been going nearly 3 hours today. Oh, it's a good one today. Much progress. Yeah, we've been going 3 hours today. That's enough for now. Yeah. Alright, so we'll pick up this on the next stream. If you enjoyed it, don't forget to click the like button down the bottom, or if there was anything at all that was mildly useful or entertaining, click the like button. Thanks. And just remember, folks, it's only software. How hard can it be? We'll find out.